Hello and welcome back to my world map tutorial series. In today's episode we will extend the functionality of our markers and fix some of the issues that came up in the last episode. However, before we start, I just quickly wanted to show you that there is a new version of Unreal Engine, which is 4.20. So this new version will be used for the rest of the entire series. And I've already tested our map project on this new version and it doesn't break anything. So feel free to install the new version of the engine and convert your project to 4.20. Back in our project, we ended up with a couple of issues in the last episode. So when we hit M and right click, we are actually able to place markers. But the first issue is that if we zoom in, their position is off, and we also see that the size of the markers does not change. So that means when we zoom out, they appear too large, and when we zoom in, they are a bit too small. So let's fix these two things first. And for that, let's go into Actors and to the BPC world map. Here we can simply add a function that we will call update marker positions. What we have to do here is very simple. We will just cycle through every of our marker widgets and set their position again, because our location to map position function already takes into account whether we are zoomed in or not using the map size in X and map size in Y variables that are changed. So that is very simple. We just grab our current markers and run a for each loop, then hook this up to the execution. And for every marker we will break the array element, because here you see that we've got a variable which is the widget. Off of it, let's check whether that is valid, so whether it exists, and hook that up to the loop body. We will not worry about the color and marker actor, so we can actually hide these pins. And if it is valid, let's drag off of the widget again and set the render translation, so its position. To grab the new position, we'll simply call location to map position and hook that up to the translation. The location it's asking for is simply the world location. And for the widget size, we have to expand our settings category and get the marker size variable. Then let's make a vector somewhere here. Make vector 2D. Hook that up to the widget size, and our marker size will feed into both X and Y. After we've completed our loop, we can simply return. And let's compile and save so that we can call this function. We have to call it when zooming in or out. So both of these cases use the modify map size function. Let's go in there. And right here we update the player position on map. Simply after that we'll call update marker positions. And connect that and hook it up to the return node. That should already work. So if we compile, save and play, we can open up our map. Let's zoom out. Right click somewhere and place a marker. Then if we zoom in, the position of that is adjusted properly. However, we still get the issue that the size is not changed. So our marker appears extremely small compared to the player icon. Let's say we want to make that an option like we did for our player, whether we want to keep the size when zooming. So simply add a variable and we will call this keep marker size when zooming, question mark. Of course, type here is a boolean. To make it a setting, we'll make it editable, exposed on spawn, and put it in our settings category. Then let's compile and save. You can actually rearrange it by simply dragging it onto the minimum zoom, so that the key player and key marker size are beside each other. So our variable here, the marker size, will keep track of the current value of it, which might change when zooming in and out. So it does not necessarily have to be 35, which it is right now. To keep track of the original value, let's add another variable called original marker size. And let's also make that of type integer. And this can actually be a private variable, so let's check that. Basically what we want to do is when initializing this widget, we will set it to the value of marker size, and that we can only do in our event graph. Somewhere down here is the event initialize map. And we are already setting some original size variables here. So let's just add a bit of room and also set the original marker size. Hook it up to show map and simply drag in the marker size variable from the settings, get it, and hook it up. Compile and save. Then let's add a function called update marker sizes. And this is also very simple. So again, we will cycle through all of the marker widgets by grabbing our current markers, running a for each loop, then breaking the array element and looking for an isValid node for the widget. Then let's hook that up. And we can select our break node and hide unconnected pins. Then let's drag off of the widget. And fortunately, we already implemented a function called updateSize there. Let's hook that up to isValid. And like I said, our marker size variable will keep track of the current value. So let's drag that in and hook it up to new size. Then once our loop is completed, we can go into a return node. Okay, let's compile save this function. The only thing left would be to go into our modify map size function. And at the very end here, where we are updating the marker positions, let's add a bit of room. Because here we want to drag in our keep marker size boolean and add an if statement or branch off of it. Hook that up to the update player position node. If it is true, we can just proceed with what we had before. So go into our update marker positions. But if it's false, which is the default value of this boolean, we will set the marker size and hook that up to false. And to figure out the new value, we will simply drag in the original marker size and multiply that by a float, which is our current size multiplier. And to make it an integer again, we can round this. Or you can also use truncate if you want. After we've set the marker size, we can call our update marker sizes function. And then we would also want to update the marker positions. Let's compile and save. Because this should already be working. So if we play, hit M to open up our map, let's zoom in and place a marker here. You see that the size is larger than what we had before. And if we zoom out, it appears much smaller. You can also change this by just selecting your key marker size and let's set it to true. If we then play and place a marker, it will always have the same size. Okay, so let's reset that to false. And another issue right now is that all of the markers that we place are just white, which is not something that we want. So let's fix this now. We want to add a variable in our VPC world map called marker colors. And this will be of the type linear color. It won't be a single variable, but an array of colors. And to make it a setting, again, hit editable, expose on spawn, and put it in your settings category. This array needs at least one element to work, so let's compile and give it a default element. And let's just say that will be an orange with an alpha of 1. The idea is that we'll cycle through all of the elements in this array. So once all of the colors of this array have been used, we will start all over again. And for that we need a second variable that we will call available colors. This will be of the same type, so a linear color array, but this time we can make it private. And when starting the game, all of the marker colors should be available. So let's go back to our event initialize map. And maybe here, before we show the map, we'll set available colors to marker colors. And let's hook that up to the execution chain. Then we need a way of figuring out the color that will be used for the next marker. So let's add a function and call that pick marker color. It will have one output. You can simply call that out. So that will be the color to use, and type here is a linear color. Then simply what we want to do is drag in our available colors, and we will just get the first element. So get a copy at index 0, and let's promote that to a local variable called local color. Let's hook that up. Because this color was now used, it is no longer available. So let's copy over our available colors and remove an index being 0. After that, we want to check whether our available colors are now empty. So copy it over, get the length, and we want to see whether that is less than or equal to 0 and add an if statement. If it is true, means our available colors is empty, and then we will simply set it back to the marker colors, so reset it. And go into the return node afterwards. If it's false, we will directly go into the return node. Then the only thing left to do would be to hook up the local color to our output. Alright, let's compile and save. We still have to tell our system to use the color that we picked, so that we have to do in our event graph. Let me quickly close all of the functions. And here somewhere up here there is the onMapClicked event, where we're adding the marker. Currently the marker color is just set to white. before we call this function, we'll execute pick marker color and plug in the output for the marker color, then hook it up to the execution, compile, save and playtest. Now what should happen is that all of our markers should now be orange, and if I right click, that is exactly what happens. If you want to define more than one color, you simply select your third person character, then select the player map in the components, and you can add some marker colors. So I'll add 3 elements. Let's say the next one will be blue with an alpha of 1, and the last one will be red. If we then save and play, open up our map, the first marker to place will be orange, next one will be blue, and the last one will be red. And after that we'll start with orange again. And this will loop infinitely. Another problem at the moment is that all of our markers are permanent. So if we place them, there is no way right now to remove them. So that is something we definitely want to fix. And we want to make it so that when we right click an existing marker, it will be removed from our map. And for that, let's go back into our PPC world map component. And let's add a function called remove marker by index. Then add an input, because we need to know about which index to remove. So call that index, type integer. And first off, we want to check whether that index is included in our array of current markers. So get your current markers. And there is a nice function for that called isValidIndex. There you can simply hook up the input and you get a boolean whether this index can be used. Let's add an if statement and hook it up to the function. If it is false, we can't do anything, so just go into a return node. But if it's true, we will add another branch. And this time we want to check whether the available colors contains an element. And basically we want to see whether the color of the marker that is going to be removed is included in the available colors. If not, we want to make that color available again, so it can be used for the next marker. And to check for that, you get your current markers, then get from that, add the input index, break it, and hook up the color to the contains node. Then we'll plug that in for the branch. So if it is already contained, so the color is available right now, then we don't have to add it. But if it's false, we'll get our available colors. And to make it so that the color is the next one to use, we don't want to add an element, but to insert an element. And that we want to do at index 0. The color being the color from our break node, which is now available again. After that branch here, let's drag off of the marker actor, so the representation of a marker in the actual level. Currently this is just our particle system of sparks. And we want to destroy that. Destroy actor. Then hook it up to both the true path and the false path. After that, there is the widget from our break node that we also want to destroy. So remove from parent is the function to use. And to entirely remove it, you can copy over your current markers and also remove an index there. And that will also be the input. Okay. We already used the remove index function a couple of times, so you have to remember that it shifts the indices of all of the elements after the one you're currently removing by -1, so that there are no empty indices in your array. Right now that would be a problem, because if we have a look at our widgets folder and the W marker, then head over to the graph, we are using an index variable here, which would no longer be correct if our index is changed. So what we have to do is run a for each loop for our current markers. And just to make sure that the indices are still correct, we'll break the array element and only show the widget. Check whether it's valid. And if it is, we can drag off of it and set index. The new value to set it to will simply be your array index here. And when that is completed, we can go into a return node. Let's compile and save. So nothing else is required for removing markers. The only thing left would be to call this function somehow, and that we can only do from within our w_marker. Basically what we want to do is when we right click it, we want to remove this widget. So first off, let's select our w_marker in the hierarchy and set the visibility here to visible so that we definitely hit this widget with our mouse input. Then we can hop over to the graph and override the OnMouseButtonDown function. First off, we only want to do something if it's the right mouse button. So off of your mouse event, look for is mouse button down, and for the mouse button here, simply look up the right mouse button. Then add a branch and hook up the return value to the condition and the branch to the execution. If it's false, so that could potentially mean that we hit the left mouse button, then we'll go into a return node, and for the return value, type in unhandled. So that way, this function will be delegated to other widgets at the same position. If it's true, we first want to go into a do once node. So that is simply to make sure that we can't spam the right mouse button and maybe remove the same index twice. So it's just to prevent bugs. Then we want to grab our map reference and remove marker by index. Hook that up to completed, and the index will be our index variable. So now you know why we had to update the index variable. And after that we will also return, but this time the value here will be handled. Okay, let's compile and save. Let's do a quick test. If we play, open up our map, right click somewhere, the marker is added. Then if we right click again, it was removed, and you also see that the sparks back here were removed. And if we add a marker and hit the left mouse button, nothing happens, but we're actually able to move our map. And that is just because we are using the unhandled here. If we were to use the handled for the false path and play, then place a marker and left click it, we're no longer able to pan the map because our marker widget is consuming the OnMouseButtonDown function and it's not delegated to our map widget. Okay, so let's remove the handled and plug in unhandled again. The last feature that we want to add is that currently we're able to add an infinite amount of markers. We want to restrict that to a maximum amount of available markers. So let's do that in our BPC world map, and we can close the marker widget. We won't return to it. Let's say we want to make the maximum amount of markers a variable. So hit the variable button and call that max amount of markers. This will be an integer variable and also a setting, so editable, expose on spawn, and in our settings category. Let's compile and set up some default values. So let's say by default you're able to place 5 markers. The way we want to use this variable is that if the value is greater than 0, so like 5, that will simply be the maximum amount. If it's equal to 0, we won't allow placing markers at all. And if it's less than 0, so something like -1, we will simply interpret that as the player being able to place an infinite amount of markers. So how do we do that? We simply go into our onMap clicked event and at the beginning add a little bit of space. Then look for a node called compareInt. And the input here will be our max amount of markers. So get that, hook it up, and we'll compare it with 0. Remove the execution pin here. So if it's less than 0, you're able to place as many markers as you like. So we'll simply go into our spawn actor node. Basically the functionality we had here before. If it's equal to 0, we simply won't go into anything. So nothing will happen. And if it's greater than 0, we need to add a little bit of functionality, because then we need to grab our current markers array and check how many markers are there at the moment. So get the length of it. Basically, we want to see whether that is greater or equal to the maximum amount of markers. Simply copy that and add a branch. Then hook that up to the greater path here. If it's false, means we're still able to place markers, so simply go into the spawn actor node. But if it's true, means we reach the maximum amount of markers, and then what we will do is we will remove marker by index and simply remove our very first marker with the index 0. And that means that then we're able to place a new marker, so simply go into your spawn actor node. Let's compile and save. If we hit play, open up our map and right click a couple of times. Right now I've placed 5 markers, and if I place another one, The first one will be removed and it was added at the new location here. If we were to close a component, select our third person character in the level, select the player map, and let's say we want to set the maximum amount of markers to 0. Then if we play, I can right click and nothing will happen. And if I set the maximum amount of markers to something like -1, there will be no restrictions for us, so we can place an infinite amount of markers, just like we had it before. Alright, that's it for this episode. In the next one we'll talk about undiscovered areas on our map and how we can reveal them, so see you then.